Good afternoon and welcome to this problem solving session for the NPTEL course Transition Metal Organometallics Principles to Application. So myself Sujit Kundu will continuing this session in every Sunday from 4 to 6 p.m. as a problem solving session and doubt clearing session from this July to September or July to October semester in this autumn semester. So we have already completed the fourth week of this course, and now we have also entering the fifth week. So that is that most of the courses, that is half of the courses, is about to finish, and we have discussed so many things, starting from the introduction of organometallic compound, and then we have come to a point where we are discussing the most interesting and more challenging concept in chemistry, that is the CC and CH bond activation. The CH bond activation reaction we have already covered in the last week, that is the week 4, and now we entered in week 5 where we have discussed extensively the CC bond activation reaction. We have discussed many series of problem, that means the many equation where the CC bond activation happens and to give the value added organometallic compound, and also we have seen which bond can be active and which cannot. So with that I will continue this session as a problem solving session first, and after that when the problem solving is over we will good afternoon, and so we will first do some problem solving session. That means we will discuss some basic problems which has been discussed in this week, that is the week 5, and after that we will discuss some important topics or important points which has been discussed in this week. So I will wait for another 1 minute or 2 minutes to wait if anybody joins. After that we will start the discussion of today's content. If you have any doubt regarding this week content, you can ask me before that, so that we can clear the doubt and more detail as possible, as detailed as possible. Then we will start discussing that problems. Let's wait for 1 minute. If you have any doubt, you can ask me. I will try to explain it in more detail as much possible. Okay, then if not, then we will start discussing the questions from today's. Yes, do you have any doubt regarding this last week content? Good afternoon.
Yes, sir. Good afternoon, sir.
Do you have any doubt from the last
Till now,
week?
no doubt, sir. Like, I have not completely referred, but I am referring one by one.
Okay, so let's start this today's session by solving
Yeah.
the questions.
Fine, sir.
Okay. Okay. So in this week we have discussed the C bond activation from the experience of our past week, that is CH bond activation. So knowledge of CH bond activation will help us to understand the details of or process of CC bond activation. Why the bond activation is required? Because we want to functionalize the CH bond with some other functional group. Let's say if you have, I already discussed in the last week, if you have the methane and there is a CH bond, if you activate one of the four CH bond in the methane and put a chloride, then it will become the methyl chloride. If you active the 2 CH bond and 2 chloride, then it will be dichloromethane. So in this way, so different important molecule can be achieved by the CH activation reaction. So CH activation reaction we have discussed, and another challenging bond is to active is the CC bond. So we have discussed this CC bond in last week. So first we will discuss some questions on that and try to understand how CC bond is activated, and after that we will see some basic topics or basic points which should be remembered when we are uh, reading or understanding the or solving question for this from this topic. Okay, let's start. So first question is, between the C6H5CH3 and C6H5H bonds, C6H5CH3 bond has a higher dissociation energy than C6H5H bond. Which will be the right answer from this question? So this question is comparing the bond dissociation energy.
Sir, is it option C? Because electronegativity for both the atoms are same, like CC and CH, so electronegativity is negligible. So I guess it should be having equal bond dissociation energies.
Okay.
Yes,
Okay. Okay. So CH, so you are saying that both will have the same bond dissociation energy. So let's go to the
yeah.
PDF where we are reading this. Why CC bond is more challenging to active and how? Yes, so lecture 121 is started for this week 5 content. So we have seen one slide here which is very useful to remember. Here you can see the CC activation is more difficult than HH and CH activation, even though HH bond in H2 and CH bonds are alkenes are 40 kilojoule per mole stronger than CC bond. Okay, so this is one point. Another point is we will have a comparison between the different bonds like the CC bond, CH bond and the CF bond. So from that we will get the value of actual bond dissociation energy. After that I will discuss why the CC bond is more difficult to active than the CC bond. So if you consider the energy wise, so we will see that CC bond dissociation energy. So here you can see, so where it is CH3 and C6H5H, so BDE means the bond dissociation energy.
Yes, sir.
So you can see that, so for C6H5CH3, the bond dissociation energy is about 427 kilojoule per mole, whereas for C6H5H, that means benzene, the bond dissociation energy is only 368 kilojoule per mole. So why I am showing the slides, because the question which is asking is not a single question outside of the content which has been projected during this week. So this is the week 5 and lecture is I think 22 or 23. So this is that you can see that bond dissociation energy BDE is 427 kilojoule per mole for C6H5CH3, whereas for C6H5H the bond dissociation energy is 368 kilojoule per mole. So from this comparison you can see that the C bond is more higher dissociation energy than C6H5. So here
C6H5H. A.
option A will be the right answer.
Fine, sir.
Okay. Okay.
Yes, sir. Fine.
So here the electronegativity has no role, and also the other option you can see the both the bond have equal dissociation energy. Absolutely not, because CC bond dissociation energy will be always more compared to the CH bond. Also both the bonds are extremely air and moisture sensitive. So you can see this option is actually wrong, as this is a C6H5CH is a toluene molecule, and whereas C6H5H is a benzene, and
Benzene.
both are highly stable in air and moisture. So option A will be the right answer for this
Yes,
question.
sir. Fine, sir.
Next question is the CO insertion into the RFM, where RF is a perfluoroalkyl bond. So this is the CF activation.
Yeah, CF.
So CF insertion is does not occur, that is it does not occur at all. It readily occurs at elevated temperature only, occurs at low temperature.
I'm not sure about it, sir.
Okay.
But one thing is like there is a electronegative negative difference between fluorine and carbon. That is correct.
So what will happen for that? So CF bond are highly robust, because
Robust.
the electronegativity, you can see that owing to the high lattice energy of the metal fluoride decomposed product, the RF complexes are thermodynamically less stable or inert than the RH metal complexes. That means the complexes are highly stable. So you can see that the sigma complexes is sigma complexes, alkyl complexes. So here in this example CF3CO 9, which is a fluorinated compound, and our concern question is the CO
CO
insertion.
insertion.
CO insertion. So here we have a example for that. I will discuss this after this slide. I will discuss after the question is over. So here you can see the CO insertion of RFM bond is unfavorable. Here you have the R. Here you have the R, and when it is heated, what is happening? One of the N, that is the CON, is removing from the metal carbonyl, and it is inserted between the alkyl and metal. So when it is R equal to H, that means this is an alkyl group with H. So when this is H, these undergo readily. But in presence of fluorinated, when R equal to RF, that means CF3.
Yeah, yes, sir.
CF3 is rare and only at the elevated temperature. Okay.
That is at high temperatures you are saying.
So
high temperature this will
also
take
high
place.
temperature is required to elevate this CF bond.
Sir, one more thing, RMCO bond, that is R is alkyl chain, right? So which means like R is actually carbon, right? Or it is hydrogen?
No. Here it can written, no?
No, sir, like previously you mentioned RMCO, not RF I'm saying, just R. Like the PDF you showed, PDF. Adobe Reader, PDF. R, here it's mentioned RMCO.
So here you can refer that R is, let's say, CH3.
Okay.
And here R will be CF3.
CF3, okay.
Okay. So
Yes.
R means carbon attached to the hydrogen.
Hydrogen.
Here RF denote carbon attached to
Attached
the
to fluorine.
So that means it's a fluorinated carbon atom.
Yeah.
So here also this result occurred because high stability of this RFM bond. So their CO insertion occurs only at the elevated temperature. Okay.
Yes, sir.
So the right answer will be, which will be the right answer?
Occurs at elevated temperature, C.
Option C.
Yes, sir.
Option C will be the right answer. The next question is to predict the product of this reaction. So these types of questions are very interesting, and some reaction have to remember. We try to understanding the logic in it.
Yes, sir.
So here we have a cyclopentadiene moiety where is fused with a cyclopropane in this carbon junction. So what will happen? This Fe2CO2 Fe2CO9 C6H6 in presence of 80 degrees centigrade. So what will happen? These will form a complex. Why? Because this is a 5-membered ring,
Yes, sir.
and another 5-membered ring infused in one carbon atom. So that means this ring is highly strained.
Yeah. It is pyro compound.
Because of this high strain in presence of iron, it will try to remove its strain.
That's why ring expansion takes place.
That's why this carbon and this carbon, either of these above one or below one, because both are same, will undergo
dissociation.
That means CC
bond dissociation takes place.
Activation.
Okay, yeah, CC activation.
CC activation will take place, and it will form also. When this will take place, this system will undergo the aromatization.
Okay, sir.
Okay, so for that it will become more stable complex. So what will happen? So Fe2CO9 we have, so it will undergo that this opening of this CC bond and forming this as a aromatic ring. So which will be the option?
Option B.
Yes, option number B.
B.
So here this CC bond will active. This will form a sigma alkyl complex with the iron, and this will gain the aromaticity. That's why it will be more stable and it will react steadily.
Okay, sir. But sir, on what basis is it is aromatic? Because it is attached to metal carbon bond. That's why it's aromatic.
So this is 6 pi electron system now. Cp minus.
Okay, sir. Okay. Six per. Okay, 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 okay. You are saying okay.
You got it?
Yes, sir. It follows Huckel's 4n plus 2 pi electron rule. Okay, sir.
And we are considering this part only.
Okay.
This is 6 pi electron system, Cp minus.
Yes. Yeah, yeah, yeah. Correct, correct. Yeah.
6 electron, 4 electron.
4 electrons is anti-aromatic.
Huh.
6 electron means aromatic, sir.
Yes. Okay.
Okay, sir.
The most challenging bond to active is
CC bond.
so we will see. So most challenging bond is active is either it is CC bond, HH bond, CH bond, or CF bond. Okay. So here there is a table where you can say that the activation energy of different bond. So that means it says that bond energy. So bond energy means these bond contain this much of energy. So if you want to break this bond, that means to dissociate this bond, you have to give energy equal or more than this to active this bond.
Yes,
Okay.
sir. Yes, sir.
So for the CF bond, the bond energy is 450 to 500 kilojoule per mole. For CC bond, the bond energy is 350 kilojoule per mole, and for CH bond, 410 kilojoule per mole,
Yes, sir.
and HH.
Really much lesser than CH bond.
Yes. So if you to increase the order of bond dissociation, what will be the lowest? Will be option A.
A.
Then
Option C.
option C or option B. Look at this PDF.
Yes, sir. Option B. Option B. C should be the right answer.
CC bond. So here CC bond is
C.
there. So CC
Oh,
bond,
okay,
then
okay, sir.
CH
CC
bond,
bond.
then CF bond. Okay.
Okay, sir. Then CC, CH, CF. Okay.
So here it will be option number
B. B.
B. So CC bond,
BC
then
bond.
option number
C.
C, then
Then D. I'll just write it
D.
down.
So that means this is the bond energy order. That
Yes, sir.
means the bond energy increases. So that means that if the bond energy increases in a particular bond, to break it or dissociate it will need more energy.
Yes, sir.
Okay, that's why it suggests that the CF bond energy is higher. CF bond energy is higher, so this bond is more difficult to activate.
Okay, sir.
Okay.
Yeah.
So option number D will be the
D.
right answer for this. Okay. RFM. This is also very interesting or very interesting question. So RFM complexes are stable owing to RFF means
Like alkyl chain attached to fluorine. Instead of hydrogen, it will be fluorine.
this is
CF3M.
metal. So this is RFM.
Yes, sir.
So RFM complexes are stable owing to option A, metal carbon overlap increased as a result of contracted m orbital arising from higher partial charge on metal. Option B, same, metal carbon overlap decreases. Same. Option C is lower energy pi star MO of RF facilitates the RF to metal back bonding. And higher energy facilitates the metal to RF back bonding. Any idea?
Need to check, sir. So you can refer to the PDF.
I will refer. You just tell me whether you can get the answer or not.
Is it B?
Okay.
Yeah.
Okay. Let's explain this question. So, in other than this, in a general, very general way. So, see, the question says that RFM complex are stable. So when a complex becomes stable, and here we are considering the stability. Stability in respect to that two things. One is that orbital overlap, another is the back bonding. So let's say if you don't know the answer, so if a compound becomes stable, that means two orbital overlap is strong or less.
Orbital overlap is strong.
That means option A says that metal carbon orbital overlap increased. So if increased leads to the stability.
Yes, sir.
So RFF complex stable because of we know that the much orbital overlap, it will be more stable. So obviously option A will be the right answer.
Yes, sir.
Okay. Another thing considering is that back bonding. So metals are already positively charged.
Yes, sir. Electropositive.
Electropositive.
Yes, sir.
And fluorinated compound are, this means that CF3.
Yes, sir.
This one is fluorine is attached.
Yes,
So
sir.
fluorine has high electronegativity.
Yes, sir. It tends to pull electrons from the carbon.
Huh. So the if we say that the group electronegativity of CF3 moiety will be higher,
Yes, sir.
so when the electronegativity is getting higher, so what will happen that it will decrease its pi star level. So
Like
what
if it is like if the more electronegative atom is attached, then the
the
pi
pi
star
star
atom
level will be
decreases,
more stabilized.
which means it will go to low energy.
Yes.
Okay.
So it will go to the lower energy state, and
Yeah.
when it goes to the lower energy state, that back bonding from, that means energy will be compatible from the metal, so that back bonding it will be easier to transfer the electron from metal to
Metal to this RF.
RF. That will also be the more overlap or give the more stability.
Most stability. That will like metal will facilitate the back bonding with RF.
Yes, so option number
C.
C will be
Okay.
the.
MSQ2.
So this question is MSQ.
Okay.
Okay.
Like during exams, sir, they won't be giving they won't be saying whether the option, the question is MSQ or MCQ or something. Like we have to identify ourselves whether it is MSQ or MCQ,
No.
right?
Yes. So in the exam, I think two exam in the question will be divided in two or three parts, I think.
Okay, sir.
So the the first part, or I think third part, will be exclusively MCQ, and in one of the part of the question will be MSQ. But the problem is, when this is MSQ, there may be some question which is MCQ. That means only one option is correct.
Okay, sir. Yeah, yeah, okay.
Okay,
Yeah, yeah, yeah.
you got the point, right?
Yes, sir, yeah.
So
But sir, computer, the exam will be CBT mode, right?
yes,
Okay.
so one part of the question will be combination of MCQ and MSQ.
MSQ. Okay, sir.
Okay,
Fine, sir.
so here you got the answer. So just have no knowledge, if you don't have any knowledge on RFM, just by thinking of the stability, how complex or compound becomes stable, you can get at least one answer correct. That is, obviously overlap will be increased, and that's why it become more stable.
Yes, sir.
So option A will be the right answer. Next question is, predict the product of the reaction. So these types of questions, some questions will be there, many questions will be there where you have to just predict the product of the reaction. So for that, you have to just remember reactions which are important. Let's say fluorinated compound. So so here what will happen? So what is the total electron count for this compound?
Just a minute, sir.
So manganese,
CO5 minus.
manganese is D5,
D5S2, 7 electrons,
7 electron,
plus 10 electrons.
plus 5 carbonyl is 10 electron,
Yes, sir.
then
Plus 1 electron,
plus 1. That means it is
18
18
electrons.
electron system.
Yes, sir.
So what will happen?
So like metal will attach with the this cyclobutane, right?
Yes,
By removing one
cyclobutane.
fluorine atom.
But which fluorine? Let's say if I name it, this is 1 or this is 2, because both are symmetric. So instead of which fluorine it will attached?
Which fluorine?
It will attach to it instead of CF. 1 fluorine or CF2 fluorine?
I would say CF1 fluorine.
That means option
Hello?
number B.
Yes, sir. B, yeah.
But it will attach to that fluorine which is attached to CF2.
CF2.
It means option number
C.
C will be the correct answer.
But sir, how it will be possible? Okay, like because by can we do by counting using 18 electron method?
Now 8 electron method will not count here. Why not? Because you see this complex is negatively charged,
Yes, sir.
whereas this complex is neutral, and this negative charge on the metal center mainly act as a nucleophile to
Nucleophile.
attract here and to remove this fluorine.
Okay, sir. Okay.
Any of that. So here this complex is also 18 electron. There is no elimination of CO. Both contain 1, 2, 3, 4, 5 CO. Only this negative charge acts as a nucleophile and it undergo the CF activation via and finally the substitution through this reaction.
Yes, sir.
Okay. Okay. So next question is between CF3COCO4 and CH3COCO4 the incorrect statements is are. So you should able to get this answer as per discussion is already done. Between CF3COCO4 and CH3COCO4 the incorrect statement,
Hmm.
just highlight it incorrect.
Yes, sir. It is wrong. The wrong statement we have to
You have
find
to
out.
understand the wrong statement.
Let me see. Check. Sir. So one can be option C.
Okay.
C for
So
cow.
let's discuss this. So in the last question, this question,
Yes, sir.
we have discussed that the RF complexes are highly stable because of their increasing overlap
Overlapping.
and lower energy pi star MO.
Yes, sir.
But here in this question, it says that CF3CO show higher melting point. CH3 higher melting point means complex are stable
I
or
didn't get you, sir.
unstable.
So you're saying something? I didn't get you.
So CF3COCO4 shows higher melting point. That means this complex is
Stable.
stable. Then CH3 shows a higher boiling point. CF3CO is stable at room temperature. That means it is also correct, because we have seen that CF3 complexes are stable, that's why is giving the higher melting point. So option A correct, option CO correct. But coming to the CH3 complexes, the CH3 complexes is stable at 100 degree? Absolutely not, because we have seen that CH3 complexes or methyl complexes easily decomposes. So as it is not stable in 100 degree, so its boiling point thing will be not very higher, because it is complex decompose before the melting. Many complex decompose before it reach its melting point or boiling point. Okay, so it's incorrect. So this option A and option C are correct statement. So incorrect one will be option B and option C.
So how come these two are like correct answers? Is it mentioned in the PDF?
Yes, yes, it is mentioned. You want to see?
Yes, sir. Please show it to me.
So where we are considering the CH3. Do you have this PDF? This PDF is not but just the lecture slides which has been seen in that thing. I already shown these images.
Okay, sir. Okay.
So CF3 complexes are highly robust. Robust means they are highly stable, whereas
Yeah.
CH3COCl complex is easily decomposed as minus 30 degree. So
Yes, sir.
complex which decompose as minus 30 degree does not mean any stability or boiling like that. So okay,
Yes, sir.
got it right. Next question is option number 7, 8. Next question. Challenges. That means when you see this type of yes or in the last question is or are, so there is a probability of MSQ. There is a probability. Okay, it is not that always that where this kind of thing is there it should be MSQ. It can be MCQ also, but there is a probability that it should be MCQ with MSQ question. So challenges of CC bond activation arises from option A, the inaccessibility of the CC bond, less abundant nature of the CC bond as compared to CH bond, the difficulty in forming the initial pre-complex with transition metal, the highly reactive nature of CC bond. Okay, so we have seen that the CC bond energy is, last question, CC bond energy is less compared to the CH bond
CF.
energy.
Yeah.
Okay, so that means the CC or যদি বলি bond energy or better to write bond dissociation energy. So Cc less than Ch. But still the activation of Cc bond, so bond dissociation energy less means it should be more reactive compared to the CH bond, isn't it?
Yes, sir.
When you have the bond is less energy, that means less energy required to active this bond, but it doesn't happen. Why? This is the reason that the inaccessibility of CC bond. Why inaccessibility? Because let's say a ethylene molecule CH3 CH3, right? So for ethylene molecule you can see that is C bound to C. There is only one CC bond, but here we have 6 CH bond and 1 CC bond. So inaccessibility of CC bond, that means when metal will approach to this molecule, it have only one CC bond which it can approach, and the CC bond is surrounded by the CH bond. So metal cannot approach the CC bond easily. So in spite of having less bond energy, it is not activated easily. Last is the less abundant nature of CC bond and compared to the CH bond. So for considering this organic molecule CH3CH3, we have only one CC bond, whereas we have 6 CH bond. So number of bond available for CH is more compared to the CC in a particular system. That means the CC bond are less abundant. It is also correct. Option C, the difficulty in forming the initial pre-complex with transition metal. Why? Already said that CC bond is surrounded by the CH bond. So the transition metal cannot approach the CC bond directly or easily. So the initial pre-complex formation is not easy for CC bond. So that is also the reason of challenges to active the CC bond. So in spite of having lower bond dissociation energy, the CC bond cannot be active easily like the CH bond. The last question is high reactive nature. Obviously, if the CC bond is high reactive, so it will be activated easily. There will be no challenges. So this is not the correct answer. So option D is not correct. So only option A, B and C is the correct answer to this question. Next question is, you got the answer right?
No, sir, I didn't understand actually.
CC bond activation is more challenging. Why? That is the reason. The bond dissociation energy is less as compared to the CH bond, but still it is more challenging because the inaccessibility of CC bond, as CC bond are surrounded by the CH bond, it is not able to access properly to activate less abundant nature. That means for this molecule we have one CC bond, whereas we have 6 CH bond. So that means number of accessibility is less and different difficulty is forming. As the CC bond is surrounded by the CH bond, the metal cannot approach to the CC bond easily to activate it. That's why CC bond are very challenging to active. Okay. The next question is question number 9. Predict the product of the reaction. What will be the product? So this is a CF activation reaction. Okay. So here this is FeCO5. That means iron is D8 plus 10, 18. So initial complex is also the 18 electron complex. So when an 18 electron complex, a neutral complex, will undergo that activation or addition, it should be something should be eliminated. So for FeCO, the CO ligand eliminates, as we have already seen, some heating or some presence of H nu, that is photon, one of the CO molecule easily eliminate. So this will eliminate to generate that 16 electron species, then it undergo the reaction.
Could you explain once again, sir?
So what will be the answer?
I'm not sure about it, sir. Very good.
So what will happen? You can see This is a process of oxidative addition reaction, as our initial complex is 16 18 electron. So first it will lose one of the
Option D, sir.
option.
D. D for dog.
Yes, because you have already answered here. Okay, so here the iron center will undergo the oxidative addition by a removal of one of the CO moiety to give that option, give the corresponding product. Here iron is iron in plus 2 oxidation state. Okay, next and the last question is, we have seen the reason for that why CC bond is challenging to active. That means why it is challenged to active the CC bond.
Yes, sir.
Now we have the solution. So why the CC bond activation is challenging?
One, I can say option B. Lazy formation complex.
Yes. Not one. That is there's only one option. That is it is a MCQ.
Yes, sir.
So CC bond is activated often achieved by. That means this is one of the procedure or one of the criteria to active the CC bond. That is option number B. We have
Yes, sir.
already seen this example that cyclopentadienyl.
Yeah, like two fuse cyclopentadiene. When it reacts with Fe2CO9, then the ring opens it to form a
in the
6 member
presence
ring.
of
The metal is attached to it.
Fe2CO9. So this ring is opening to
Yes, sir.
give that cyclopentadienyl CpFe 1 2 2 3 3 4 5, like this.
Yes, sir.
Okay. So with this completed the 10 question of this week. If you have any doubts till then, you
Also,
can.
one more thing, like in this reaction, like how many carbonyls will be there?
Yeah, that's FeCO5. Now you calculate that 18 electron rule.
FeCO5. Like, so what about the 4 carbon atom that got released?
So if this molecule is the structure I've shown, na? So this molecule is Fe C double bond O C double bond O.
Okay, sir.
So then we have the terminal COs. So here one CO 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 CO. So another one is C double bond O O. This is the structure of Fe2CO9.
Okay, sir. So the mechanism mentioned in the book, right?
No, it is not a mechanism type. So this bond is actually opening, and as because of the ring strain, and here it will be Fe2CO2. Because it has to satisfy is CO2. So iron is 8 plus Cp ring is what? How many electron?
5 electrons, sir.
5 electron.
Yeah.
Then 2 carbonyl group is
4 electrons.
4 electron, and 1 alkyl chain, that is
1 second. That is 2 electrons.
why 2?
So
Where
one
it is
electron.
CH3 it is 2.
No,
It
sir.
should be
One.
1. That
Minus
is 18.
9,
To
10, 18
satisfy
electrons.
this 18, it will be 2 CO.
Okay, sir.
Okay, that will be the most stable, and remaining CO will be leave, because he has to satisfy his 18 electron rule.
Yes, sir.
Got it?
Yes, sir.
So I think this is completed.
Fine,
Let's
sir.
go to that PDF, and another this question is also an important question. This reaction Fe,
Oxidative cyclization.
yes, oxidative cycle addition, FeCO5, it undergo the reaction with this and forming a fluorinated metacycle ring. This also can be asked in the exam. Okay. So from the starting, let's discuss one thing, that here why that fluorinated or perfluoro alkyl transition metal complexes are highly stable. So CF3, so F is highly electronegative element, that's why its delta negative charge will be high compared to the CH3 delta negative, because of the high electron withdrawing power of the fluorine. So with that, transition metal, that is Tm, or you can write just M, so delta positive charge it will be. Now as the charge increases, so high the potential, so their orbital reading to interact more. Let's say we have 2 plus charge and 2 plus charge, whereas we have 2 minus charge, and we have 1 plus charge and 1 minus charge. So obviously the 2 plus 2 plus interaction, 2 plus 2 minus interaction will be more. So this ionic interaction is more compared to the transition metal fluoro alkyl complexes. That's which gives the higher orbital overlap. Also, that high electronegativity brings the pi star orbital of the fluoroalkenes lower, so that metal can donate this pi electron in the through pi star through back bonding, which also provide the stability. That's why fluoro complexes are more stable compared to the normal transition metal alkyl complexes. Another is that same the bond dissociation energy. So as the fluoro complexes are more stable compared to the normal transition metal alkyl complexes, so bond dissociation energy will be higher. The more the stability, more the bond dissociation energy. More the stability, more the bond dissociation energy.
Okay, sir.
So bond dissociation energy dBe will be higher for this compared to.
Yes, sir. Fine. That is because of this overlapping concept and all.
Yes.
Thanks, sir.
And as the fluoro complexes are more stable, we can distill out. At this also not decomposing at 91 degree, whereas the corresponding alkyl complexes decomposes only at 30 degree, minus 30 degree, not even room temperature. This is decomposes minus 30 degree. Okay.
Yes,
Then
sir.
this reaction is another very important reaction. So here so what is happening? So we have this methyl group.
Yes, sir.
Within this PME2 and PME2. Now in presence of rhodium catalyst, what will be? This will undergo the CC
CC activation.
and it will form the oxidative adduct, because
Yes,
here
sir.
it is rhodium 1 and here it is rhodium 3.
3.
Which one is 3 negative? That overall charge is positive, neutral, 0. So 1 for this chloride, 1 for the methyl and 1 from the phenyl, that is aromatic, this one. Okay. This carbon. So that means sodium undergo the oxidative addition kind of a reaction. So here it is like very basic system, that is that orbital overlap. So for the cyclopropane ring, so when cyclo 2 orbitals is very simple, so I did not discussing it. So this is sigma, this is pi, this is sigma and this is pi. So this can be which orbital of the metal? These two.
Vacant orbital, right?
Vacant orbital, obviously metal vacant orbital, but which within dx square minus y square dxy
Okay, well, like
dyz
that, understand.
dxz, another is dz square. So which two
Might be
is,
dz square,
yes, so this can be d z
z
square,
square.
which can form a sigma bond, and this can be pi bond can be d.
Pi bond is dx square minus y square.
What is the shape of dx square minus
Oh,
y square?
what else? Dx square minus y square, and dx will be involved in this sigma bond, sorry. dyz or dxz can be
Yes,
pi.
so dxz and dyz will be responsible for pi bond
Pi
formation,
bonds.
and these two is responsible for sigma bond
Sigma
formation,
bond.
and dxy is responsible for delta bond
Delta.
formation,
Yes, sir. Okay,
which
done.
is not here.
Yes,
Okay,
sir.
so the structure, what is the structure of the orbital? So dz square will be like
dz
this.
square, yeah, there'll be a dumbbell.
Huh,
There'll be like a ring.
huh.
dz.
And so this is that internuclear axis.
Yeah.
So this is along the axis.
Yes, sir, along the axis. Yeah.
And dx square minus y square will be similar.
Between the axis.
The dx square minus y square. This is also
Okay, yeah, okay, dx, okay, along, yeah, along the,
along
along
the
the axis.
axis.
Yeah.
And rest of the three is in between the
Between the
axis.
axis. Yes, sir.
So we are considering our sigma bond formation only along the axis.
Yes, sir.
So these two orbital only can form the sigma bond.
Yes, sir.
Okay.
Yes, sir.
This question is also a very important question, or is an example of CC activation reaction. So what is happening here? Here you can see there is a cyclobutane ring
Yes, sir.
which is highly
Strained.
strained.
Yeah.
So this strain he has to remove. So in presence of platinum PET3, this will undergo the again
Aromatization.
oxidative addition.
Okay, so oxidative addition. Yeah, that
Oxidative
is C.
addition.
So the first activation will take place, then only like it will be
Huh.
oxidative addition
So
takes place. Okay.
first it will oxidatively add to this. So here you can see platinum is 0 and here platinum is 2.
+2. Yeah.
Okay, so first it will undergo the oxidative addition, then another molecule of this will react to gain this big molecule, and finally this undergo the reductive
Reductive elimination.
to give the highly conjugated aromatic product and the back to the catalyst. Also here okay,
Yes, sir. Fine.
so last reaction. So this reaction is also a very important reaction. So here we have the two product formation. Okay, it's called the skeletal rearrangement. That means the formation of the product rearrange, leading to a decreasing ring size. So here we have very large ring size which is decreasing to give a ring size. Somehow you can say that the 4-member ring is forming with 80% yield, but still it depends on the energy of the starting material and the product. If the rearranged product is more stable, that means lower energy, it will go down instead of 4 member, 3 member, like this.
Fine, sir.
Okay.
Yes, sir.
Here
Okay.
rhodium will undergo the first oxidative addition, then it can be undergo the two process. One is the beta hydride elimination step
Yes, sir.
to get this compound, and after that it will undergo the reductive elimination. So
Yes, sir.
instead of beta hydride elimination, it is less strained ring is forming, but beta hydride elimination is more faster compared to the reductive elimination step. That's why most of the product forming in this form, not this form. Though this product is less strain compared to the cyclobutane ring is there, so this should be more strain, but from the process as it is happening, we can say that beta elimination reaction or beta hydride elimination reaction happen more faster compared to that reductive elimination. That's why that this compound is forming in higher yield. The next question is, or next we have seen that aromatic thing. Yes, this one we have already discussed. Here it says that what is happening over here is that aromatization of the CP ring happened, which leads to the formation of the compound, and well as the ring strain from the spiro compound. So that's why this reaction is forming. We have already seen it, and this compound is also 18 electron. But okay. Okay. So with this, we have already seen most of the reaction and most of the important topics.
Okay, sir.
Anything else from this?
Nothing, sir. I have to study everything, sir.
Any other question?
No, sir. Actually, the thing is, you just have to follow this videos completely, and then only you are able to solve those assignment problems. Am I
Yes,
right?
yes. Without watching that videos or reading this PDF, you cannot. Better to
Okay, sir.
watch the videos, because PDF, this PDF is just like a transcript of this video.
Uh,
Okay. Transcript means just like a subtitle. Subtitle is written in a book format. So
yes, sir.
without, if you don't read that, if you don't watch the video, so you may missed out which point it is denoting, which slide
Yes.
it is referring. So it is better always to watch the videos, and after that only you can solve the assignments. Is
Okay,
it
sir.
clear? Is it clear?
Yes, sir. Fine. Clear.
Okay. So when is your net examination?
Sir?
When is your net examination? You are talking about the CSR net last time, right?
Yes, sir. I actually took coaching, sir. Like I'm just taking online coaching itself.
Okay, that's good. So with online coaching, when you finish that one topic or one chapter, or let's say 2 3 chapter, try to give the
We try to solve the PYQs.
PYQs, topic wise PYQs, also give
Yes,
some
sir.
mock test
Sure, sir. Yeah.
test series. Test series is also available.
Yes, sir.
Okay,
Yes,
otherwise it's not possible to qualify because competition is getting higher.
yes, sir.
Or it is also you can try your PhD from abroad. That can
Already
also
I'm
be.
seeing that as well.
Yes.
Yes, sir.
So, doing PhD in India is a very different from doing PhD in abroad. If the professor is also not very much popular or publishing very good journals, paper in very good journal, still the exposure in the foreign countries and that handling of equipment, reactions and everything, you can also try. We are
Hmm.
also doing, or you can try that topmost institute at India where all the facilities are there.
Yes, sir. Sure.
Okay.
Okay, sir. I'll just see the lectures. I'll just go through each and every lecture properly and then understand what exactly you taught.
Huh.
To a certain extent, I've understood, but only thing is, I'm just like facing difficulty in solving these questions. I just have to brush up each and every video which I've seen.
Yes.
Yes, sir.
And this time I think portal assignments is little bit difficult, so you have to watch the videos more carefully and you
Yes,
have
sir.
to think for that problem. And
Yes, sir.
sometimes the problem is like not very straightforward as I am giving here.
Hmm.
So that problem may be just a little bit tricky but not difficult.
Yes, sir.
It is just you have to think in a way where you can get your answer. And
Yes, sir.
one thing I ensured that all the problems which has been asked in this portal or in the exam, everything is within this video, not a single problem is outside of this video.
Yes, sir.
So that is for sure, I can say. And some basic term like oxidative addition, reductive accumulation, electron count, and some question, let's say the stability question, stable up to this temperature orbital overlap, that question. So
Yes, sir.
that question is you can just ask, can answer like not only this question, several question you can like ask or you can get your answer just from just basic knowledge.
Yes, sir.
Also it is true that sometimes basic knowledge give you may lead to you wrong answer because
Yes, sir.
chemistry is full of exceptionals.
Yes, sir.
So because of that, some basic knowledge or regular knowledge of a topic may not be enough to answer a simple question.
Yes, sir.
Okay.
Yes, sir. Yeah.
Okay, then try to go through all the videos and ask or let me know if you have any doubt regarding this. Then it will the if then the session will be more interactive and I'll be also happy to explain the doubts.
Yes, sir.
Okay, then
Okay, thank you, sir. Thank you very much.
I'll wait for another 5 or 10 minutes if anybody joins. Otherwise, I will leave. Okay, thank you
Okay,
for
sir.
joining.
Uh, yes, sir. Sir, one more thing I want to say. Like, you are actually PhD scholar in IIT Bombay.
Hmm.
Okay, under which professor? Like, percentage goes.
That I cannot say. You can go through it.
Okay, sir. Your name is Shubhajit Kundu.
Yes.
Okay, sir. Okay. But sir, one more thing, like in order to get a PhD admission in IIT Bombay or IIT Madras, since I am planning to do like that, so for that we just need both GATE and NET, right? Or only GATE?
No, no, no. That is not. Both is not required. If you qualify a CSR net, that is JRF, that is obviously you will get it. Okay.
Yes, sir.
It
But
depends
what if
on.
qualify only GATE, sir? Is there any chance I can get?
Yeah, there is in I can say for IIT Bombay, there is so many student is recruiting. They are taking from the gate because
Okay, sir.
here that vacancy it's called the TA, that means teaching assistant
Yes, sir.
category. So
Yes,
in
sir.
this category, I think in every year it's taking 20, 20 or 15 to 20 student in this category. That means the your fellowship will be funded from the institute, not from the CSR or UGC or any other than this.
Yes, sir.
So, in but problem is that many professors sometimes don't want to take that,
Okay,
because
sir.
when you are a CSR or UGC fellow, you will have some amount of, let's say, I don't know why. Sometimes we also miss that CSR net or JRF value just because of just 5 to 5, 4 5 marks,
Yes,
you
sir.
will not get the JRF. So, but that doesn't mean that you are not good enough to do research.
All right, sir. Right.
So, so they are recruiting from GATE also. Even you have that, let's say, not JRF, lectureship LS, that is also applicable. So, but JRF is a criteria to have your own fellowship, to have your own research grant, to pursue your research, and to choose a professor which you want.
Yes, sir.
Sometimes the professor whose lab is highly crowded, you understand, right?
Yes, sir.
If
Yeah.
your lab is highly crowded, that means so many students are applying in the same lab. So
Yes,
if
sir.
you had a JRF fellow, then sometime the possibility of getting it become increases.
Yes, sir.
Okay, so that's why it is good to get the JRF. Or if you have a gate rank below 500,
Below 500.
below 500 400,
Okay, sir.
so then some I think below 500 is the criteria.
Okay, sir.
So then all IIT will call you because of their own uh, own own fellowship category,
Okay, sir.
institute fellowship category.
Okay,
You
sir.
just you will get the interview call.
Yes, sir. Like you just have to surpass the cutoff to a greater extent.
Huh.
Okay,
But
sir.
GATE has its separate cutoff. Let's say if you get in GATE, you will have 3000 4000 rank also.
Yes,
But
sir.
IIT sometime gives the GATE rank below 500 or below 400. So then you will get an interview call based on your GATE score if you don't have CSR net.
Okay, sir. Fine.
That's good. If you perform well in the interview, you will all get the admission.
Yes, sir. So the interview will be like how? Like it will be like basic questions, right? Like which you have studied for GATE.
Actually, in interview depends on you in which category you want to take your admission. Let's say, in chemistry we are dealing with three categories. Let's say inorganic, organic, and physical.
Physical. Okay, sir.
Also, so if you apply for a physical topic in the for the interview,
Hmm.
after getting call in the interview, you will have to choose which committee you want to give your interview. Is it a physical committee, is it an inorganic committee, or is it an organic committee?
Okay, sir.
Okay, so let's say you want to pursue your PhD in a physical chemistry, physical topic, physical
Yes, sir.
chemistry topic. Let's say kinetic study,
Or like
thermodynamic
batteries, fuels,
study,
like
let's say
electrochemistry.
chemistry. So then you have to give an interview to the committee which is expert in that that area.
Yes,
So
sir.
your question will be asked from that area. If you
Yes, sir.
want to
Right.
want to pursue your PhD in organic chemistry, you have to give an interview to a team which are doing the hardcore organic synthesis or catalytic organic catalysis transformation.
Yes, sir.
So that depends the which committee or who you want to do your research. After all, this is the first thing, and second thing is when you are applying, when you are getting an interview call, they will ask you with which professor you want to pursue your PhD. Okay,
Yes, sir.
so your question will be asked also from the research topic of that particular professor. Let's say if you want to
Yes, sir.
do uh, supramolecular chemistry or
Yes, sir.
material chemistry, that is MOF, metal organic framework. So
Yes,
then,
sir.
if you want to pursue PhD in that topic, your question will be asked from that topic.
Yes, sir.
First, they will ask some general question. After that, they will go to the particular topic in which you want to pursue your PhD.
Yes, sir.
Is it clear?
Yes, sir. Clear, clear.
Okay. Okay then.
Like for like, sir, first they'll be asking like which area you want to pursue PhD, and
If,
then like
if
why.
it is inorganic, then you will be asking some inorganic questions for sure.
Yes, sir.
Then they will ask you with which professor you want to do your PhD.
Okay,
Okay.
sir.
Let's say if you say I want to do PhD in electrochemistry,
Yes, sir.
so they will ask some questions from electrochemistry.
Yes, sir.
Okay. If you
Okay,
do
sir.
PhD in organic chemistry, so first they will ask some organic reaction, organic transformation point of. If you want to do, let's say, then you say that I want to do asymmetric catalysis.
Yes, sir.
So they will ask questions of chiral chemistry.
Chiral chemistry. That is RNS configuration
Huh.
and this
So,
polarization, depolarization. Like
huh.
okay, it's rotated, rerotated.
Or
Okay, sir.
asymmetric synthesis reaction.
Okay, sir.
When there will be retention of configuration, when there will be inversion of configuration, like that.
It is SN1, SN2, those
Huh.
mechanisms.
So,
Okay, sir.
so that is only depends on in which subject you want to do your PhD.
Yes, sir.
Okay.
Yes, sir. Okay, sir. I got it, sir.
Okay then. Thank you.
Thank you, sir. Thank you very much.
Okay then. We have a good discussion with that uh, questions answer along with that topic which has been taught in this week, that is the week 5. So I'll upload this video in the recording sheet, so whoever is watching these videos from the recording sheet list, I'll ask them to join in that live session from every Sunday from 4 to 6 p.m. and to get your doubt clear. And after that, we'll discussing some questions which is based on the topic which has been covered in this week, and which will give you a better idea or detailed idea of the course content which has been taught in this week. And also, if you have any doubt regarding your chemistry thing or your preparation of chemistry thing, you can also go through it. Main motive is this session is to interact with the student which in the learning mm, from this course. So it is hopeful I'll be happy if you'll see you in that live interactive session. With that, I think this is enough for today. So I'll try to prepare some more questions from that from next day to to extend the discussion. And just another again requesting, if anybody joining this or watching this series from that YouTube, you can just log in or join that live classes or live doubt clearing sessions to have your doubt cleared. Okay. Okay, let's say wait for another 5 minutes if anybody come, otherwise we'll stop it. Okay, as nobody is there, we'll stop this session. We'll see you in the next session, that is next day, that is 31 of August, 31 of August, for the week 6 content with the question answer. Thank you for watching and joining.